All right, so we're picking up just tracking Grandpa Simpson's retirement savings until it runs out. Still got just under 40,000 left. Still getting interest. And again, you guys will pipe up if I make a mistake. Okay, so we're now keeping track of some cents as well. 42,843.90, 22,000, 843.90, 22,000, 843.90. Multiply that by 1.1. I'm sure glad we have the technology. This is a little tedious. Okay, so I'm caught up after year 7. We got to be careful with year 8, though. After year 7 is over, he has 5,128.29. Did you guys get that too?
Yeah.
Okay. So that's what he starts year 8 with, 5,128.29. That will get interest. So we can still do that. That's going to get interest. Bumps him up to 5,641.12 to the nearest, round to the nearest cent. But he doesn't have 20,000 to withdraw anymore. He now can just withdraw whatever's there. So we're going to say he's going to withdraw 5,641.12, and then it's all gone. Can you guys humor me and just total up how much money did he withdraw in total over those 8 years? So $20,000 7 times, plus that little bit extra. We'll make a couple semi-obvious conclusions, and then we'll start doing some more satisfying, realistic problems that are applicable to you guys. So what do we got? We got 7 times 20,000. I should be able to do this in my head. And then plus that extra bit at the end. Okay, so even though Grandpa Simpson started with only 100,000, he was able to stretch that money into even more. And he was able to withdraw more than 100,000 because while it was still in his bank account, it continued to get interest. So let's make a couple of, again, I think they're pretty obvious conclusions here, but let's jot these things down. First thing we notice, he was able to withdraw a total that was more than the original $100,000 saved up. Big idea is once you're done working, you can your retirement savings, you can still stretch those out. You can withdraw more than you had saved up. This is good for us. The why of that, we'll just add in here too. While he is living off his savings, they continue to get interest. Those things might have been obvious to you guys, but now we just have a little visual to go back and just like verify. Yes, this over this 8 years, his $100,000 was able to stretch into even more. Okay, so we're gonna do some just living off of money type questions. The fancy word for these questions is we're finding the present value of an annuity, but more or less it's basically we've saved for retirement. Now we're ready to live off that money. How much interest do we make? We're going to just do a few of these questions together. I did tease out that next week our final performance task is on financial planning for somebody. So you guys now know how to help somebody save for retirement. And now we're going to start talking about how to live off that money. Expectations. Everybody will have to be able to use a solver. The 3 people, there's an equation we will use for some of these that I'll show you guys in a second. I do apologize. I believe on your handout that this heading for example 1 is on the previous page. I apologize for that. Let's dive in with the question. So let's say I think I will need about $3,000 per month to maintain my current lifestyle when I'm retired. A very realistic goal or a very realistic problem for people to have is like, well, how much do I need to have saved up? Because people know what their lifestyle is. They probably know what their budget is and how much money they spend per month. It's a realistic question. How much do I need, PV, to have saved up so that I can live comfortably off this money for X number of years? So let's dive in. How do we do this? So, like yesterday, our N does not mean years in our annuity problems, but it doesn't mean deposits here as well. Now we're withdrawing that money over time. So our N will be how many withdrawals we're doing. I am making my money last for 25 years, and I'm withdrawing my money every month. So I'll be making 25 times 12. I think that's 300 withdrawals. It's basically the same idea as yesterday. We're just withdrawing now. We are given an interest rate, but unlike yesterday, we're not starting with nothing and finding a PV or finding an FV. Here, we're finding a PV, and after I withdraw all my money, it's all gone. My FV is 0. I am taking out $3,000 per month. So my PMT, unlike yesterday, I'm putting in positive $3,000 because now I'm getting that money, right? I'm withdrawing it, comes into my hands. And our PPY, CPY, nothing has changed. This is a monthly problem. These will match in these kinds of problems. So yeah, how much money do I need saved up so that I can stretch it out to 300 withdrawals of $3,000? Let's find that out. You guys all know how to use a TVM solver at this point. It's just the number crunching. But then maybe we'll calculate a bit of interest for this one. So let me play catch up here. 300. Was it 6%? It was 6%. 3,000. Just a new type of problem we're doing. Just as an aside, one thing that a few people have noticed is that they say I'm getting something different, but all their fields are correct. It could be worthwhile just tapping on the field you're solving for again and just making sure it's good. I haven't had that problems on my PC here, but yeah, look, did you guys get that as well? About 465,000. All right, let's jot that down. 465, 620. Wrong sheet. 465, 620. I'll get the cents in here too, even though they might not, factor in too much. What are the cents? 59. Ho-hum, so he would have, why am I writing like a sucker? I can type. He would need, what is that? 465, 620, 59, over 465,000 to make his money last 25 years. Living this way for 25 years, he would need a lot saved up. What the interesting thing is, so you guys already saw yesterday how much free money you get by starting early and just making little deposits over time. Not only do you make a crazy amount of interest while you're saving for retirement, let's find out how much interest Mr. Smith made here just in the retirement phase. We're not even talking about the saving up phase. Over these 25 years, 300 withdrawals of $3,000. How much is that? I know you guys could use the mental math for that, but 300 withdrawals of $3,000. That is $900,000. So I've almost doubled my retirement savings by not just taking it all at once, but by maintaining a reasonable lifestyle and just stretching it out over 25 years. You guys can mentally see the interest. The interest is almost $450,000. So very cool. Other things you guys can do in this question, we found the PV for this lifestyle, but you could change the problem. What if I needed my money to stretch out 30 years? Well, you would just change 25 to 30, And just humor me, guys. Let's go to our TVM solver. This is me. I work at a bank now. What if I needed to make my money last for 30 years? 30 times 12 is 360. Well, I would probably need a bit more saved up. I need $500,000 saved up. So you guys can make easy little tweaks here to determine what you need to save up. But we can do more types of questions too. So check this one out. So let's use the same interest rate as part A. And can you guys, if you want to be lame, you can just use what I'm doing here. But you guys play financial advisor for this one. So it's a same interest rate from the previous question, so 6%. FE would be 0. We're still using PPY, CPY is 12. But you guys pick a lifestyle and pick a time in years. So if you want to do what I'm doing, let's blow through our money in 10 years, and let's have a monthly budget of 10,000. You can feel free to do your own. Like you could be a financial advisor. But yeah, let's live lavishly for 10 years. So I am taking out 10,000 per month here. 10 times 12 is 120. How much would I need to live this crazy lifestyle? It's not that hard to find, dude. It's just TVM solver, number crunching, the ones and zeros. Life is good. $120. We're finding that. So yeah, if you're doing the one I'm doing, I would need, look at that, $900,000 saved up just to make my money last for 10 years. Wild stuff. All right. So that's the one type of problem we can do. Let's just wrap this one up. What did I get? 900,734. And I'll be good and get the cents to 53. All right, so sometimes people don't know what their lifestyle is going to be. In other words, we're turning this around. Some people might know, okay, I have this much at retirement. What can I afford to take out each month or week in order to make my money last? So we can do other types of problems too. So let's do this example here. So let's say we've got 300,000 saved up for retirement. The same account as example 1, which means the interest rate is, we're still using the same interest rate, 6%. So 6%, it's a monthly question, 12 and 12. FE will be 0. But let's pop in our PV as minus 300,000. We've invested that 300,000. So a legitimate question is, I have this much saved up. I need to make it last for 20 years or 30 or 40, whatever you want to do. How much can I take out each month? The TVM solver can do that. It's just in this type of question, we're solving for a payment. So 20 years of monthly withdrawals. So the TVM solver can do this, a different type of retirement question, a different type of question, living off money. Given a present value, you can find a withdrawal amount. And it's not hard to do. We're just putting things into our TVM solver. So let me play some catch up here. 240, we've saved up 300,000. 12 and 12. Did you guys get 2,149.29? Yes. Okay. Let's just jot that down. If you didn't get that, just tap on it again and resolve if you have my fields. Otherwise, it's user error. Uh, 2149.29. 2149.29. So as a financial advisor, you could say, hey, client, you could withdraw $2,149.29 each month. Your money will last exactly 20 years. And then after that 20 years, well, you're screwed, I guess. No more money for you. Hopefully you're living with your kids at that point. They're taking care of you. All right. Last type of question you guys can do is a little variation of the previous one. So we have 300,000 per month. This is what it will the withdrawal we could do to make our money last for 20 years. But sometimes you might want to know, well, what if I want to take out more? How long will my money last? You guys can just tweak what we did. This time you know the PMT, and we can solve for N. So let's just do a little tweak here. Let's solve for N. Same account, 6. 300,000 saved up. This time, we're going to take out 10,000 each month. FB is 0, 12, and 12. So far, I think you guys have been. You guys would be able to get away with having incorrect signs. It is important here that we have a negative PV and a positive PMT. We've invested the 300,000. We've given it away, and we are getting back the money. Otherwise, you get either a nonsensical answer or an error message. So clearly, this should last less than 20 years. Let's find out how long it will last. So you guys can imagine this is you next week. You're planning for somebody. You can give them options. Hey, your money will last for... Now, guys, remember, that's not years, right? This is, if I may, can we just round this to 33? This isn't years, that's 33 months. You can make 33 withdrawals. We'll round that to 33. How long would that last? Well, 33 divided by 12. I mean, it's 33 months, but you can do, to get the years, divide by 12 here. 2.75 years is how long the money would last here. All right, and again, we could tweak. We could say, how long would it last if I did 5,000 or 2,000? But guys, can you guys humor me here? And excuse me, I want to show you guys one last type of problem to do. Can you guys head to your TVM solver, and let's say instead. Now I just got to be careful to make sure this works. It's monthly, right? Times. Okay, this will work. Can you guys put in $1,500 for PMT and solve for N? That's a big number. Did you guys get that as well? Yeah. That's months. How many years is that? I don't know. 6,000 divided by 12? 505. Basically, yeah, it's like 500 years. Can you guys humor me one more time? Can you guys put in $1,499 and solve for N? I'm trying to break this thing. I broke it. Is it not giving anything to you guys? Yeah. Why isn't it giving anything? It's not like we have any signs wrong or weird things put in. But guys, as an aside, can you guys just jot this down at the bottom here? Our interest rate is 6,000. Guys, listen up. This is important. You guys can use this next week. It's all important. Just listen all the time. 6% of 300,000. You can do that on your calculator. It's 0.06 times 300,000. That is 18,000. That means each year on this 300,000, if we didn't touch it, you get $18,000. What's that per month? If you divide that by 12, that's $1,500 per month, which means if instead you were only to withdraw $1,500 per month, what would happen is you would actually just never run out of money. because you're making 1,500 in interest and you're skimming off the interest. You'd actually never get to FV is equal to 0. So something to keep in mind for next week too. If you guys could humor me, I've said that a few times. Bear with me here. One last thing you guys could do, just for fun, keep this in mind. Can you guys do this for me? Can you actually put in, let's just do a different scenario here. Put in, I don't know, $500,000 for PV. But can you guys put in $500,000 for FV as well? Make sure one's negative, one's positive. Put in any number you want for n. I'm going to put in 1. And then I want you guys to solve for PMT. And this, I'll do it in a second too. Can you please humor me and try this? What this setup is saying is, if I start with $500,000, what can I withdraw each month to still have $500,000 afterwards? So if we solve for PMT here, so financial advisor, you could say, hey, look, friendo, you could take out $2,500 each month and never run out of money. In fact, whenever you die, you would still have $500,000 to leave to whoever, right? So you guys aren't stuck saying FB is 0 all the time. That's why I said 90% of the time. You can do questions like this where you your money just continues to last forever because you're living off the interest. All right. Anything you guys want to chat about? I'm going to pause the recording. 3M people are ready to go on the assignment I have.